Okay, here we go. Excited to see you again back with us looking at squares, square roots. Today we are looking at I can find the squares and the square roots of whole numbers. We are looking at factoring. So we are attempting to do this sans calculator here today. So let's take a look real quick. A factor, once again, is a number that evenly divides into another number. So if we're looking at our examples here, we have got 1 times 6 is 6. 2 times 3 makes 6. So the factors of 6 are 1, 2, and 6. 1 can multiply by 6. 2 can multiply by 3. Okay. If a factor multiplies by itself only once, you only write it once, you're going to have an odd number, right? So 1 times 4 is 4. 2 times 2 is 4. So you would label those factors 1 and 4. But 2 only comes once. It doesn't have a pair because you're multiplying it by itself. All right, so let's take a peek through and take a look at this chart. So it says fill in the factors below. So there is one number that is a factor of every single number. That number is... I was going for like a Dora kind of pause where you would yell out 1, and I'd say good job. I wasn't sure if you answered or not, though, so I didn't say good job. But good job if you answered. So 1 is going to be a factor in every single number, because no matter what the number is, you can multiply it by 1. So that being said, we also know that if you can multiply it 1 and it should have a partner, another factor is going to be the number itself, okay? Because 1 times that number. So if we have 1 times 1, that's it. That's all we got. If we got 2, we can go 2 times, we can go 1 and we got a factor of 2, okay? So 1 times 2. If we have 3, we can go what do you multiply? What are factors? What are things you can multiply together to make 3? 1 times 3, that would work. What about 4? Here, 4 is a little unique. So we got 1 times 4 can make 4, and 2 times 2 can make 4. So we're going to put 2 in there, but we're not going to put it twice. We're only going to put it once. So keep going, go all the way through and fill out all the rest of this chart. Pause this now and fill out all the rest of the chart with all the rest of these things. Awesome. Thank you for pausing it. Let's see how you did. So we've got factors of 5 is just 1 and 5. That's it. 6. We got 1. We have 2. We can what do we multiply 2 by to make a 6? 2 times 3 is going to be a 6, and 1 times 6. Awesome. What about 7? Can you multiply anything together to make 7? No, just 1 and 7. What about 8? 1 times 8, we know that one. Okay, so can you multiply something by 2? 2 times 4, that works. And 8, because you can't go anything times 3, anything times 5, anything times 6. Okay, let's take a look. And what about 9? We can look at 1 times 9, and 9's another special number called a perfect square. Yes, exactly. Good job. And so we have 3 in there. And we're only going to put it once because we only have one of them. What about 10? We know we can go 1 times 10. We can go 2 times 5. Can we do anything in there? 3, 4, no. So 2 times 5, 1 times 10. Okay, let's try 16. 1 times 16. 2 times 8 is going to make 16. 3 times something? No. But 4 times 4 is going to make 16. 5, 6, 7, no. But 8 we have in here, and we have 16 up there. 22, what about that? We've got 1. Can we multiply 2 by something? Yes, we can go 2 times something. Can we go 3, 4, 5, 6? No. But we can go 2 times 11 to make 22, and we can go 22. Okay, what about 25? We've got 1 times 25. Oh, 25 is another perfect square. We can go 5 times 5. Any others? Not really. 25. 30. 30, we can go 2 times 15. 3 times 10. Can we go 4 times something? Not really. But we could go 5 times 6. So there's a pair. What did we say? 3 times? 3 times 10. 2 times 15. And 1 times 30. Okay. Now we got 36. Let's go again and take a look. It's an even number, so we know definitely 2 is going to work. 36. 3 is going to work. Is 4 going to work? 4 is actually going to work in this case. 4. Is 5 going to work? No. Is 6 going to work? Yes. Now, 36 is also special because 6 times 6 is 36. So now we're going to start partnering off the opposites. 4 times 9, 3 times 12, 2 times 18, and 1 times 36. Okay, so we've got all the different factors. You can see they kind of like get more and more and more as the numbers get bigger, except some of them, even though these ones are getting bigger, sometimes there's a few of them that aren't getting any bigger. They aren't changing at all. So we've got, say, this one, this one, this one. Oh, missed 3. We've got 7, doesn't have any extras. Any other ones in here? Not really. What do we call those ones? Oh, we're looking down here. They only have 2 factors. These numbers are prime. So let's put a P in there. P, 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 P. Okay. Take a moment in here if you've got a paper copy in front of you. What are a couple other prime numbers that would only have like 1 and that number? Pause this video, write a couple more in there, or just pause it and think about it in your skull. What'd you come up with? Awesome. Great numbers. Let me tell you what I came up with. I came up with 11, 13, 17, 19. Any of those, we can only multiply by 1 and that number. So those ones are our prime numbers. Okay. Which numbers have an odd number of factors? Okay. So we've got like 2, 2, 3. Let's switch to a different pen color. How about, I don't think I've used this one. Or maybe that's that one. The Life of a Colorblind. I'm going to go with, can we see yellow on here? Okay, so let's look at this. 4 has only 3 factors. What else do we see with only 3 factors? 1, 2, 3. 9 has only 3 factors. 25 has only 3 factors. 2, well, 2 only has 2 factors. But what are some, oh, there we go. What are some odd numbers here, right? We've got 4, 9, 25. Any others? Oh, I guess 1. If we had these, we would call them what? That's right, perfect squares. 1, 4, 9, 25. Oh, I think we missed this one. 1, 2, 3, 4, 5. 16 is in there. 25. And we remember that they are special because these numbers, it's a number multiplied by itself. So this is 2 times 2. This is 3 times 3. This is 4 times 4. This is 5 times 5. What would be the next couple of these odd number factors? If we follow our pattern here, we'd have 6 times 6, 7 times 7, 8 times 8. What would these be? Pause this video for 2 seconds and come back. Yes, exactly. Some of you We didn't notice 1, 2, 3, 4, 5, 6, 7, 8, 9. You're like, Highland, that's an odd number of factors. So we're going to have 36. Then we're going to go up and have 49. Then we're going to go up and have 64. We have all those numbers are odd numbered factors. And so they might have just a couple, or they might have a whole bunch, but it's going to be an odd number because that number in the middle is going to be multiplied by itself. And so any of those means it is a perfect square. Okay, so let's keep going with this. If we move down a little bit, we can see, okay, we already talked about this. These are perfect squares because they multiply by itself.